I love math, the way the path goes on the graph, how it functions. Cause great discussion in the math class, shall put no textbook before the math class.
Hey guys, let's go over question number 1. Given x minus 5, write the 0 that corresponds to each factor. So this is a factor, and you're used to seeing something like this, right? They were factored, and now you can drop the parentheses. You don't need these, and you're just setting this one equal to 0, and then you're just solving. X equals 5. This here is now a 0, and that would be choice C.
Given x equals 2, write the factor that corresponds to each 0. Well, in this case, I want to set it equal to 0. So I'm going to subtract 2 from both sides. My factor is x minus 2. If you'll notice that none of these have x minus 2, your answer is E. Question number 4, find the remainder. If you'll notice the hint over here, all I have to do is write f of x. What does that tell me? Every x value I'm going to replace with -2. Now you could do something complicated. You could set that, you could find a factor for that. Add 2 to both sides and you got x plus 2, and then you can use long division if you really wanted to. I wouldn't recommend it. You could take x equals -2 and then do synthetic division, still find the remainder. But here, it's kind of set up to do the remainder theorem. What does that mean? You just take the number and substitute it in. Every x value, you're going to put in a -2. Don't forget to make sure you're putting your substitutions in parentheses. -2 cubed, remember you're using PEMDAS. So I'm going to do exponents first before I multiply. -2 cubed is -8. -8 times 2 is 16. -2 squared is +4. -6 times 4 is -24. -3 times -2 is +6. And then you have 15. And if you add all those numbers together, you get -19. Question number 4, your answer is B.
Okay, so the first things you should recognize is that this is a binomial. 1, 2. If you had your factoring flowchart, it would tell you to, number 1, could you add a 0x, or in this case a p. So let's see if I do that. You're adding this placeholder. Now, in this placeholder, now you have a trinomial, 1, 2, 3, and then if you can take half of 3, and this is the number, then you can actually factor this by Xbox method. Now let's just say you did the placeholder to be 1.5. You'll recognize that the problem is prime. So, which means you cannot use Xbox. So no Xbox. Why? Because you need an A, B, and C, and so both these conditions, half of the exponent is not 1.5. Okay, so now you're left with the same thing, original problem, 8p to the third minus 1. There is no greatest common factor. But one thing you should recognize is that if it's a binomial, 1, 2, and you can take the cube root. The cube root means 3 identical numbers that multiply to be 8. Another way of saying that is something to the third power equals 8, so that would be 2. 2 to the third power equals 8, or 8, the cube root of 8 is 2. Now, put that in your calculator just to show you. Here I have a TI plus CE, so I'm going to go to the calculator commands are math, and scroll down there to number 4, and you put in the number 8, and it gives you 2. And then if you do the same thing for 1, 3 identicals that multiply to be 1 are 1. Now, the cube root of p to the third is just p, because p to the third power is p to the third power. What does this mean? Your a value is going to be 2p, and your b value is going to be 1. Basically, you have a difference of cubes. So in this problem, my formula is always going to be the same with a's and b's. A, b, a squared, a, b, b squared. And then we talked about the SOAP. That's why I chose to teach high school, because you use SOAP. Same operation. Opposite of the negative is a positive, and AP always positive. And then you just do your substitution. A is 2p, B value is 1. A value, be careful here, is 2p. So essentially this is 2p squared, which is 4p squared. A times B, so AP times 1 is just, or 2p times 1 is just 2p. And then B squared is B value, 1 squared is just 1. So 2p minus 1, 4p squared plus 2p plus 1, the answer is A. Now, just a reminder that this trinomial here is prime. You cannot factor that again.
Factor completely, you should always, I loved it because one student actually just wrote this. GCF. Every question says factor, they just wrote GCF. Good idea, good idea. It does have a GCF. The GCF is, go a little quickly, faster, is 6x cubed. Remember, if you expand them all out, 6x to the 5th, there's 5 x's, 4 x's, 3 x's. You'll notice that they have a 6 and 3 x's as greatest common factor. If you got to this point right here, then I gave you, I think, 3 points only. You got a 2 if you found just a common factor. Here in purple, if you make your X box, A times C is 3, B value is -4, your two numbers are -3 and -1, and they go there. So you would have to have this as full credit. Show all your work and explain, is x minus 3 a factor of this polynomial? There's actually 3 ways to solve it. You don't have to choose all 3, and I'm sure hopefully you did one of the 3. You can use the factor or remainder theorem, you can use synthetic division, or you can use long division. Let me explain the remainder theorem. Set the factor, get a 0, substitute in every x value, simplify. 27, 9 times 12 gives you, I don't know, 108, 51 and -30, and if you add those all together you get 156. If you did a synthetic division, you're using the x equals 3, you have 1, 12, 17, and -30. Synthetic division just tells you to bring it down, multiply, add down, multiply, add down, multiply, and you get 156. So each of those methods will give you 156. If you chose to do long division, x goes into x cubed, x squared, multiply, 1 minus 1 is 0, 12 minus -3 is 15, bring it down, x goes into 15x squared, 15x times, multiply, 15 minus 15 is 0, 17 minus -45 is 62x, bring it down is -30, x goes into 62x, 62 times, multiply, and you'll still get 156. Is it a factor? The answer is no. It's not a factor because there's a remainder. If you drew yourself a polynomial, and this is my polynomial, it's a cubic, y-intercept of -30. The question is, what's happening at x equals 3? Does it cross the x-axis? The answer is no, it doesn't.
Given x to the 4th minus x squared minus 12, factor completely. So I have a trinomial. 1, 2, 3, that's an A, B, and C. And if I can take half the exponent, let's see if we can take half the leading exponent, x to the 4th, so the 4th, half of 4 is 2. This is good when both these conditions work. You can use x box, so let's do x box. Your A, B, and C, your A value is 1, so A times C 1 times negative 12 is going to be negative 12. And then my b value is going to be negative 1. Two numbers that multiply to be negative, or 12 is 4 and 3. And they need to add to be negative 1. So this one is going to be there, negative. Negative 4 times 3 is negative 12. Add those together, you get negative 1. Now, let's say you don't know the shortcut. Just take those two values. They will always go there. Remember, they're splitting the middle term. So the first term will always go into the top left. The yellow here, negative 4 and 3, are splitting negative 1. So you have to add an x squared. And the last term, minus 12. Just take out your greatest common factor, x squared, minus 4, and then plus 3. And then double check by multiplying, and that works. So to factor completely, I have x squared minus 4 and x squared plus 3. But here, if you would recognize, you have to factor that one again. And that's why I drew a kind of a big space right there. If you had put a 0x here, you would have gone a times c is negative 4, your b value is 0, and your two numbers are 2 and negative 2. So to factor the red, it would be x plus 2, x minus 2. And then this one would just be x squared plus 3. What was the shortcut I was talking about before? Remember, when you're doing this x box method, you only have to do the x when a is equal to 1. If this number is greater than 1, you have to do both x and the box. So to summarize, a is equal to 1, just use the x, and if a is greater than 1, you have to use the x box. But if you forget and don't know that shortcut, you can actually do both and get the same answer. Alright, second step is now find the zeros. How do I find the zeros? Well, these are called factors. I don't know, an obvious way to kind of explain that is they have parentheses. To find or identify the zeros, or solve for the zeros, or just solving, I'm going to set each of these equal to 0. And then you just basically solve each one of these. Subtract 2, x equals negative 2. Add 2, x equals 2. Subtract 3, x squared equals negative 3. How do you get rid of the power of 2 there? You have to take the square root. We talked about previously, if you take the square root of an equation, it's plus or minus. And then you have the square root of negative 3, and the factors are negative 1 and 3. Square root of negative 1 is I. So there, this 0 is x equals plus or minus I radical 3. Again, the reason why you have to write that plus or minus is because now if you take one of these, something like I radical 3 squared, I squared is negative 1, and negative 1 that becomes the square root that becomes the I radical 3 squared would just be I radical 3 times I radical 3, which is I squared times 3, which is negative 1 times 3, which is negative 3. So that proves to you, not in the red, but if you put in positive I radical 3 or negative I radical 3, it'll equal negative 3. So there's two answers that you can put in for x. Squared will give you negative 3. Okay, sketch the graph. Sketch it. Use my straight edge. I'm going to write the original problem down here just so you can see it. X to the fourth minus x squared minus 12. Alright, so negative 12 is my y-intercept. Let's write negative 12. And it's to the power of 4, so it's an even degree like a quadratic. Starts up, ends up. Leading coefficient is positive, so your arrows stay that way. And then I'm going to take x equals negative 2. Let's see what colors I got. And then x equals 2. Okay, now remember this is on the x and y coordinate, so this is the real number system. So there is no I in radical 3 on the complex, so you can just go ahead and sketch it. Now I should show some kind of turning point or extrema to there. Why is that the case? Remember the degree 4 is equal to the extrema minus extrema equals degree minus 1. We learned that previously. Extrema equals degree minus 1. So if I have 1, 2, 3 extrema and you add 1 here, you get a 4th degree polynomial. So that basically is telling us in a 4th degree polynomial you have to have 1 less for the extrema. So if I just went here and did a quadratic, I wouldn't have enough extrema. And then that's how you graph your, looks something like this. Doesn't look exactly, but it's a W, and you should have 3 turning points.
Mathematics includes the study of quantity, structure, space, and change. Math can be so complex it could be considered strange. So strange equations could be rearranged. Don't even get me started on fractions. To multiply them it's going to take a lot of action. But math can be simple, all it takes is practice. Your brain is like a muscle, make sure it's active.